What are variables in Solidity? Solidity is a statically typed language, meaning each variable's type and category must be declared. In Solidity, variables are containers for data within smart contracts. They hold values that define the contract's state and logic. Solidity variables fall into three main categories: state variables, local variables, and global variables. We will explain, each in turn using code examples and on-screen cues to illustrate. Common data types. Solidity has many built-in data types. Here are some common ones with examples. Uint unsigned integer, non-negative whole number. Example, uint public count 0. Solidity have two types of integers, int and uint. Int, signed integers, example int 8, int 256. Uint, unsigned integers, example uint 8, uint 256. Int and uint without a specified size default to int 256 on uint 256. Bool, boolean type, true or false. Example, bool public active is equal to true. Address, 160-bit value that holds an Ethereum address. Example, address public owner, often set to msg.sender. String, dynamically sized string of text. Example, string public name to Solidity. Each type serves different purposes. Use uint for counts or amounts, bool for flags, address for accounts. There are many other types, e.g. int, bytes, arrays, structs, and string for text. But the above are the basics for beginners. State variables are declared inside a contract but outside any function. They represent persistent storage on the blockchain. Any variable defined at the contract level is a state variable. These variables live in the contract's storage and retain their values between function calls, even between transactions. For example, contract my contract. String public message. A state variable stored on blockchain. Function set message string memory new message. In this example, message is a state variable. Once set by calling set message, its value is saved in contract storage. The data persists even after the function ends or the transaction completes. Note that declaring a state variable public automatically creates a getter function, allowing anyone to read its value. Because state variables are stored on chain, writing to them costs gas, so use state variables carefully. Local variables. Local variables are declared inside functions or code blocks and exist only during that function's execution. Their scope is limited to the function or block in which they are defined. As soon as the function finishes, local variables are discarded. Local variables are usually stored in memory or on the stack, and they do not persist on the blockchain. For example, function add x and y public pure returns. Here sum is a local variable. It's computed inside the function and then immediately returned. Once the function returns, then sum no longer exists. Local variables cost very little gas compared to state variables, since they reside in memory and are cleaned up after execution. This makes them efficient for temporary calculations. Global variables. Global variables, sometimes called built-in variables, are special variables provided by Solidity that give information about the blockchain or the current transaction. They are available in any function or contract without explicit declaration. For example, msg.sender the address that called the current function. msg.value the amount of way, ether, sent with the function call. Block.timestamp the timestamp of the current block, seconds since Unix epoch. Text or origin the original sender of the transaction, use with caution. These variables let you access transaction and block data. For example, address public last sender, unsigned integer public last value, function record call public payable. Last sender is equal to msg.sender, global variable, who called last value is equal to msg.value, global variable, ether sent. In this snippet, msg.sender and msg.value capture the caller's address and payment amount, respectively. Global variables do not get written to storage by themselves, but their values can be copied into state variables as shown. Solidity also provides other globals like block.number, current block, block.coinbase, miner's address, etc. These built-ins are very useful for contract logic but should be used carefully. Alright, now let's go to Remix IDE and paste our contract code. This contract has all three types of variables: state, local, and global. Compile the contract. Next, I'll click on the Solidity compiler and compile the contract. As you can see, it compiled successfully without any errors. Second step is deploy the contract. Let's first test the state variable. By default, the message variable is empty. Now I'll call the setMessage function with the bye-bye world. If I check the message variable again, you can see the new value is permanently stored. Even if I call it later, the value remains saved on the blockchain. Let's test local variable with the add function. Suppose I enter 5 and 7 as inputs. The function returns 12, but notice here, the result is not stored anywhere in the contract. That's because local variables only exist temporarily inside the function, and they are discarded after execution. Now let's test global variables. Notice that our function record call is marked as payable. This means we can send ether along with the function call. If the function wasn't payable, Remix would not allow us to attach any value. Here in Remix, I'll select 1 Ether in the value field. Then I'll call the record call function. As soon as I call it, if you check the account balance at the top, you'll see the balance of my account decreases by 1 Ether because that Ether is now sent to the contract. Check global variables stored. Now let's check the state variables. Last sender. This shows the address of the account that made the call. Last value. This shows the amount of Ether sent with the transaction, which in our case is exactly 1 Ether displayed in way. Finally, let's verify the address. The last sender we just recorded should match the account address shown at the top in Remix. And yes, both are the same. This proves that msg.sender correctly captures the caller's address. In this video, we learned that Solidity variables are containers for data and must be declared with a type. We covered 3 categories. State variables, defined at contract level, stored persistently on the blockchain. Local variables, defined inside functions, exist only during function execution and are stored in memory, temporary. Global variables, built-in variables like msg.sender and block.timestamp that provide blockchain transaction info. We also compared storage versus memory. Storage is persistent and costly, while memory is temporary and cheaper. Finally, we saw examples of common types, uint, bool, string, address, and how they are used. Thank you for watching. If this video helped you understand Solidity variables, please like, comment, and subscribe for more tutorials. Happy coding!